level. Remember that I told I use table. Mesket doesn't allow me to use table, but usually for you, I believe that using table is much easier. If you don't like to use table, you can calculate normal H in meter, W I in kilonewton, H I, and after this F I, which is equal with Ft. Remember, this one is only for roof plus 0.92 V, sum of WI HI divided by sum of yeah. Now Ft only for the roof is 0.08 V, and if you do the calculation, you will find 313.734 kilonewton. Level. Remember what I said, I start from the top, 3 or roof, two and 1. Remember what I said, H is not the high of the level, it's high from the ground to the level. And I will have 3.9. After this, let me have a look, 7.4 and 10.9. After this, W will be 1275.11, 1320.68. I know the student doesn't like a lot of writing, but this is the way in which we calculate the earthquake action. And I have this one is 13898.699, 9773032, 5170.971, and the sum of these will be equal with 228 842.702 kilonewton times meter. Now we have to apply this one, and we will have F3 will be equal with 313.734 plus 0.92 times V, which is 3921.68, 13898.699 divided by 288.42702, and will give you equal with 2052 52.328 kilonewton. After this, you will have F2 will be 0.92 times 392,168 9773.032 divided by 2, 842.7 702, and we gave you 1, 2, 2, 5, 1, 2, 6, and F1 is 0.92 times 392,168 5170.971 8842,702, and we gave you 646.8389. Remember what I said? Some of these number has to be give you this number. If doesn't give you this number, then somewhere is a mistake. And some will be 392,1.68 kilonewton, which means is okay. Okay, now we have all the information. We can find period of the building, T1 equal with 2 pi root square of, and we have the displacement, yeah, will be equal WI, which is 1275, 11 times distance at, let me see, I think, denomination D1 to D3 should be, D1 is the maximum displacement at level 3. Yeah, I need to change this one. Will be times,
Oh, it's already changed.
I changed on my, okay, I changed. On my example, I didn't change. 375.569. Sorry, should be in millimeter, yeah? In meter, we have in 0.376 rounded, plus 1320. D3 is the as I show you on this one. Here. You see, this is the biggest displacement. And what happens, if you have a look on here, you will see that this is smaller, this is smaller. Why is smaller? Because it's the mass. What happens? The force hit this first column, you don't have any weight. And after this, because of the gravity, the displacement is decreasing. And you see at the maximum is at the top, and after this you have smaller and smaller, and here because it's fixed A, the displacement is 0. Okay, 13268 times 0.279 plus 1325 1325.89 times 0.129 divide, and this should be square. Don't forget, you see I forget this, you don't have to forget. Times G, which is 9.81 times 0.328 times 0.376 plus 1,222,5,126 times 0.279 and plus 646.8389 times 0.129. It's a lot of calculation. And if you do the calculation, you will find 1.0131 second. And you don't round it at 1, you will take 1.01 second. Yeah? Always 2 digits. Always. Sorry? Yeah.
We need a bracket or not?
Well, doesn't
Right,
matter. Yeah, sorry. But the answer is right. Yeah? Any other question? Easy peasy. We did so many things. We have to find, or we move to, already we did, this was part A. Please, part B. And now we go to part C, which asks for calculate horizontal seismic shear acting at the base of the C. Calculate the horizontal design action coefficient using equivalent static method for one interior transversal frame of the building. Assume that the building has 6 transversal frames. This is information which you didn't really need in here. It's just to see if students think. Yeah? You don't need, because you have to calculate for one interior frame. Doesn't matter that you have 6, 7, or whatever. One interior frame has this, again, this is not important. Annual probability of exceedance is 50 years. Building importance level is 2. Ductility factor is 3. Now, knowing this, we go to calculate the horizontal design action coefficient, which is this one, CDT1. Yeah? And we have T equal with 1.1 second. After this, we have shallow soil. And if you go on the table, find a bigger folder for action. If you go on the table 3.1, table 3.1, you have the period of the building, and you have shallow soil, which is, you probably is good to keep the fact that is C, because sometimes one is K mu, C in here. Therefore, you have to do interpolation, yeah? T, if you put 1, sometime I forgot, is 1 second, you will have CHDT equal with 1.19 and T1 equal with 1.5 second, CHDT equal with 0.88. Therefore, T equal with 1.01 second, you have to do interpolation. Remember what I said, the interpolation can be done by addition or by subtraction. I did by subtraction this time, and I said 1.19 minus 1.19 minus 8 divided by, because difference, I put divided by 5. You can put by 0.5, it's the same, yeah? And multiply by 0.01. Yeah? Because this is what I have here. And if you do the calculation, you will find 1.1838. Now, check, should be close with this number. If it gave you 0.90, that means for sure is a mistake. You can do 0.88 plus this divided by 5, but you multiply by 0.49. And it will give you the same value. Next, hazard factor Z. Your building is in Akaroa. Therefore, either you go on the table and see where is this, yeah? Akaroa is 101. You have to download your standards, yeah? This is the table, Akaroa is 101. That means you go to position 101 and you'll find that Z is 0.3, yeah? After this we have R, return period factor. And remember I told you that the importance level is 2, importance level 2. And design working life is 15 years.
Excuse me, that 0.3, where did you get it?
Sorry?
0.3. So 116?
No. 1. Now, because you have the world standard,
Oh, this is the old one.
I think you have the new standard, yeah?
Yeah, it's on the one that I'm wondering.
Yeah. That one, you see, this kind of changes are in the standard. Few things, because was something happened in Akaramo and they change. You will see a few value from here are different from the old standard. But I'm the right one, yeah? 0.3. Okay, design working life.
7055.
Now, if
It was the fifth one.
If you look on here, 101, yeah, you have nothing on D. Therefore, here you can put, when you look there, D is bigger than 20 kilometer, yeah? Because when we find N, D, TD, we will need to know this information. Now, importance level 2, design working life is 15 years. If you go in 1170.0, you will find the annual probability of exceedance is 1 divided by R equal with 1 divided by 500. This is the table, yeah? And you have importance level 2, 15 years, yeah? And you go for earthquake, and you will find that this is 1 divided by 500. Now remember that you have to do a check. Z times R. Oh, I didn't find R, sorry. R, U equal with RS and equal with, if you go for annual probability, you'll find 1 divided by 500. No. Now you go on earthquake standard.
Oh,
Yeah, and you find R. This is, yeah, this one. Annual probability, because it's 1 divided by 500, RS equal with RU and equal with 1, yeah? And now, don't forget the check, which is Z times R, will be equal with 1 times 0.3, and this one is smaller than 0.7, which means it's okay. If it's bigger than 0.7, I didn't find any value bigger than 0.7, yeah? Even for example, if will be with, if you go for R, the maximum is 1.8. 1.8 in this case probably, but okay, we finish with this. That means we can calculate CDT, which is CHDT times Z times R times O and T. Now, I forget it. Because this one is distance is 20 bigger than 20 kilometer, always NDT and TD is equal with 1 and is in the same. What happens? If you go on here, yeah, you have this time, the annual probability of exceedance is 1 divided by 500, which means it's smaller than 1 divided by 250. And distance is bigger than 20 kilometers, that means ND, TD is 1. Yeah? If the annual probability of exceedance is bigger than or equal with 1 divided by 250, is directly 1. Yeah? But if it's smaller, and this is the, I choose to be smaller this time, to see that you have to calculate function of the distance from the near fault. And we will have 1.8 equal 1.1838 times 0.3 times 1 times 1 And if you do the calculation, you'll find 0.35514. Remember what I said, for this value you have to have minimum 4 digits, because if you have, you can play, work with 3 digits, and you will see that in the end V will have difference, important difference. Okay, now next step is to calculate CDDT1. CDDT1, the one which we assumed previous equal with 1, which is equal with CDT times SP divided by K mu. Now, remember what I said, SP, if you don't have specification about the material which is used, always SP is equal 0.7. You have in standard the explanation about this SP, I think is in section 4 or 5. What is? Yeah, it's in section 5. Yeah? And where it says that no, section 4 says unless otherwise specified, where is SP, unless otherwise in clause 442 for ultimate limit state, unless otherwise defined by the appropriate material standard, the structural performance factor for ultimate limit state shall be taken as 0.7, except where mu is between 1 and 2. And you have to calculate if the activity is smaller than between 1 and 2, you have to calculate this as SP. But in the question, mu equal with 3, that mean is 0.7. K mu is in section 5. Section 5, yeah? And you have K mu. We know that our soil is C, yeah? And also we know that the period of the building is 1.01, which means we are in K mu equal with mu for A, B, C, and D, K mu. And period of the building is 1.01, which means is bigger than 0.7. That means K mu equal with mu. T1 equal with 1.01, and soil C, that mean K mu equal with mu, and equal with 3. Therefore, we will have CDT1 equal with 0.35514 times 0.7 divided by 3. And when you do the calculation, you will find 0.08287. As you can see, is a huge difference between what we choose, what we assume there. Usually CDT1 is small. Now we have CDT1, we can calculate the base we move to point D of the point. Sorry, I forget to, you see, this is, I forget, let me see if I. We have some, two checks here. And we have one check is Z divided by 20 plus 0.02 multiplied by RU equal with, if you do the calculation, 0.035. Because you know, Z is 0.3, R is 1, and this is our value CDT1 has to be bigger, smaller, 0.035. This is smaller than CDT1. Is okay, yeah? Because remember, if it's bigger, you have to, and the next check is 0.03 times RU equal with 0.03. Again, is smaller than CDT1 and is okay. Yeah? Always CDT1 has to be bigger than this one, bigger than this one. If it's smaller, as we had the previous case, you know, last question, last class was smaller, and we took the value in here. And A, B, C, I will move in here, D. And I will leave the table because we will have to calculate again. We have all the weight. We can calculate base shear force, which is CDT1 times total weight, and is equal with CDT 0.08287 times total weight we calculated before is 3921.68, and we gave you 324.9896 kilonewton. Now, starting with this point, you can work with 2 digits. Therefore, we will come in here. You see, work smart, not hard. Yeah? Now, FT will be 0.08 times 324.9896, and will be equal with 25.9992 kilonewton. As I said, you can work with 2 digits, but because and this one, all this will stay the same. Yeah? Doesn't change, because weight, this, only the final formula will change, and I have F3 will be equal with 25.9992 plus 0.92 times 324.9896. Now, if you do the calculation, this one here, and keep, I don't know, will be easier for you to do the calculation, but 2, 8, oh, sorry. 1, 3, 8, 9, 8.699 divided by 2, 8, 8, 4, 2. And we gave you 170.0. Let's put 764. After this, F2 will be equal with 0.92 times 3, 2, 4, 9, 8, 9, 6. 9773 out 3, 2 divided by 8, 8, 4, 2, and 7 out 2, and we gave you 1 out 1.3 out 96, and F1 will be equal with 0.92 times 3, 2, 4, 9, 8, 9, 6, 5170.971 to 8, 8, 4, 2, 7 out 2, and will be equal with 53.6035. Now the sum of these equal with 3, 2, 4, 9, 8, 9, 6, which is okay. Whew. Question. You have to get familiar with standard, because if you don't know exactly where you have to go, and already the test is prepared, I print everything, I need to print the booklet for the test. And you have 15 pages from the standard. Initially I said maybe I will leave you with having look on the standard, and I said, oh, it will be hard. It's much better to put what you need, but its entire page is not only the table. It's entire, for example, when you need to find the CBT one, you have this page, and if you need to ask for